Normal distribution, also known as the Gaussian distribution or bell curve, is a fundamental concept in statistics. It describes a symmetrical, bell-shaped probability distribution where the majority of the data clusters around the mean, with tails extending indefinitely in both directions. Understanding normal distribution is crucial in various fields, as many natural phenomena tend to follow this pattern. So, the normal distribution characteristic of it is that the normal distribution is characterized by two parameters, mean and standard deviation. The mean determines the central location, while the standard deviation measures the spread or dispersion of the data. In a standard normal distribution, the mean is 0 and the standard deviation is 1. So next is the standard z-scores. To compare and analyze data from different normal distribution, we use standard z-scores. The z-score is a measure of how many standard deviation a data point is from the mean. The formula for calculating the z-score is z equals x minus the mean over standard deviation, where x is the individual data point and the mean, the symbol of the mean, and the symbol of the standard deviation. So the significance of z-scores. Z-scores provide a standardized way to assess where a particular data point stands within a distribution. A positive z-score indicates a data point above the mean, while a negative z-scores implies a position below the mean. The magnitude of the z-score indicates how far a data point is from the mean in terms of standard deviation. So let's relate the z-scores in real life. So for education, the z-scores can help interpret the individual's performance relative to the mean and standard deviation of a test. For finance, z-scores are employed in finance to evaluate an investment's performance compared to the market average. And for example, the health sciences, z-scores play a role in assessing how a patient's measurements such as height or weight compared to the average for their group for the age group. So about the z-table, z-table for standard normal distribution table provides the probability that a standard normal random variable is less than or equal to a given z-score. This table is valuable tool for statistician, researchers, and analysts working with normal distributions. The normal distribution is central to the limit theorem, stating that the distribution of the sum for average of a large number of independent, identically distributed random variables approaches a normal distribution regardless of the original distribution. So, in conclusion, normal distribution and z-scores are integral concepts in statistics with wide-ranging applications, from assessing academic performance to making financial decisions. Understanding these concepts empowers individuals to interpret data in a standardized and meaningful way. Whether you are a student, a researcher, or a professional in any field, a solid grasp of normal distribution and z-scores enhances your ability to make informed and statistically sound decisions. So we are now in giving examples. So problem 1, the scores on a standardized test are normally distributed with a mean of 75 and a standard deviation of 10. Find the z-score for a student who scored 85 on the test. So z equals 85 minus 75 over 10 equals to 1. And here is the bell curve. So the explanation for the problem 1 is the z-score is calculated by finding how many standard deviation a data point is from the mean. In this case, the standards the student score of 85 is 1 standard deviation above the mean. Next, onto the problem 2, the heights of a population of trees follow a normal distribution with a mean height of 80 centimeters and a standard deviation of 20 centimeters. What is the probability that a random selected tree is shorter than 160 centimeter? So the answer for this problem is z equals 160 minus 180 over 220 over 20 equals to -1. So using a z table, the probability corresponding to z equals -1 is approximately 0.1587. So here is the bell curve. The explanation for problem 2 is that the negative z-score indicates that the height of 160 cm is 1 standard deviation below the mean. The probability is found using the z-table. The next problem, problem 3. The average weight of a certain species of bird is 150 grams with a standard deviation of 25 grams. If the weights are normally distributed, what percentage of these birds weigh more than 170 grams? So the answer for this is z equals 170 minus 150 over 25 is equal to 0.8. Using a standard normal distribution table, the percentage is most likely or approximately 21.42%. So the explanation for problem 3 and its answer is that the positive z-score indicates that the weight of 170 grams is 0.8 standard deviations above the mean. The percentage is found using the standard normal distribution table. So, on to the next problem, problem 4. The time travel to work for a group of employees is normally distributed with a mean of 25 minutes and a standard deviation of 4 minutes. What is the probability that a random selected employee takes more than 30 minutes to compute? So, answer for the problem 4 is z equals 30 minus 25 over 4 is equal to 1.25. So, Using a standard normal distribution table, the probability is approximately 0.8944, and here is the bell curve. So the explanation for problem 4 is that the positive z-score indicates that the travel time of 30 minutes is 1.25 and the standard deviation above the mean. The probability is found using the standard normal distribution table. To the last problem, problem 5. Factory produces light bulbs with a mean lifespan of 1000 hours and a standard deviation of 50 hours. If the lifespan are normally distributed, what is the probability that a randomly selected bulb will last more than 1100 hours? So the answer for the problem 4 is z equals 1100 minus 1000 over 50 is equal to 2. So using a standard normal distribution table, the probability is approximately 0.0228. So the explanation for this last problem is that the positive z-score indicates that the lifespan of 1100 hours is 2 standard deviations above the mean. The probability is found using the standard normal distribution. And that's all. Thank you.